I would like to start my talk by asking a very simple question. Do any of you guys like theater plays? Please raise your hands. That's great. Me too. Well, I'm a molecular biologist, and that means that sometimes my job feels like I'm actually watching a theater play. But the difference is that the size of the stage is over 100 million times smaller than this stage that I'm standing on right now. During my PhD, I studied a process that is called RNA splicing. This is a process that living organisms use to try to change and modify the information that comes from the DNA. But for the purpose of this 3-minute talk, I'm just going to pretend that splicing is like a scene from a theater play, like the one that we have in the image. So the goal of my thesis is to try to see how this scene plays out. And more specifically, what is the role of one character, a protein named SRSF1, that we can imagine is this woman that is playing in the play. But you may be wondering, why is this protein, SRSF1, any important? Well, first, I can tell you that SRSF1 was discovered 30 years ago, but to this day, we're still not sure of all the things that it does. So I was very interested by that. But second, SRSF1 is one of those proteins that sometimes is in excess in cancer cells. So that would be like having 5 or 6 women playing the same character in this scene. So you can imagine how it can be a disaster for the overall play. So in the first part of my project, I was focused on understanding which other actors or proteins come in close contact to SRSF1 during RNA splicing in live cells. For this, I used a method that is called proximity labeling. This is a method that gives SRSF1 the ability to put a stamp, or a little star, or a chemical mark in other proteins that are around it. So the closer other proteins or actors come to SRSF1, the more stamps they collect. By counting the number of stamps, that's how I found PRP28. That is a protein that binds very strongly to SRSF1. And in the image, we can see it as the actor that is actually holding hands with SRSF1. What I'm trying to do right now is to try to take a very detailed picture of SRSF1 and PRP28 working together during splicing. This is going to be very important because, as I told you before, SRSF1 is one of those proteins that sometimes is in excess during cancer. So the more that we know about how SRSF1 works and with who is collaborating, the easier it's going to be for us to develop strategies that we can use to try to save the show, especially at those times when the play goes wrong. Thank you so much.